Again, as you see on the screen, today's conversation is about ignition coils. We've had some great conversations already this year, and I think this is just another one to add to the pile of great conversations we can go in and talk to technicians about. So with that, we're going to briefly talk about how they work. We're also going to talk about some reasons why they fail, talk about a few tech tips that can maybe help that technician avoid a comeback, and especially those DIY customers avoid comebacks. And then we're going to turn it over to products, talk about some really cool engineering improvements that we've done. We're going to look at the competitive landscape, which I think you'll really like, because this is going to put you in a position where there's really nobody out there that's going to be able to compete with you when it comes to that competitive landscape. And then we'll wrap up talking about some sales support, some things that we have that are going to make it easier for you to open up those conversations about ignition coils. So again, high level here, how do ignition coils work? Well, it's pretty simple. Now there are different variations. We have 2-wire, we have 3-wire, we have even 4-wire now. But at the end of the day, what we need is we need a trigger, we need a battery positive signal, we need a ground, and we need the module to do what it's supposed to do. Now, in this particular example here, this would be a 2-wire. And what you'll see that we've added to the screen here is the camshaft position sensor and the crankshaft position sensor. So when we think about coils, we have to also consider the cam and crank sensors, because those sensors are giving all that feedback to the PCM to let the PCM know where everything is relative to the crankshaft, right? So the PCM has to send that signal and let the module know what to do based on the rotation of the engine. So the cam and crank are vital here. But as you can see, what we have is we have a very basic, simple system. We have our ground, we have our positive, we have the module inside of either the coil or the PCM, and then we have the trigger. And whether that's the PCM triggering or the module inside the coil triggering. And that's going to be done based off of the rotation of the engine and the timing of the engine. So this is going to be happening over and over and over and over again. We're going to be seeing the ground open, close, positive on, off, trigger, off, on, and the coil and the module itself doing its job over and over and over again. That's really the gist of it. Instead of having a distributor, instead of having a bunch of wires, instead of having a separate module, it's all contained, whether it's in the coil or in the PCM. And so the way that that works is this. Now, this is, a spread out view. These would actually be kind of stacked onto each other. But the way it works inside the coil is we have 2 windings. We have a primary winding, which is going to be less amount of winding of coils. And then we have a secondary winding, which is going to be a lot more windings of coils, because we need to add a lot more voltage. And so the way this works is we have a circuit that's open within the system, and that's going to allow an electrical current to run through that primary winding, that red winding you see on the side there. Well, when that current is running through it at the right time and the right command, we're going to close that ground. We're going to close that open gate, and that's going to create a magnetic field that's going to expand, and that's going to activate that secondary winding. So we've got the winding in the primary building up the current. We're expanding that magnetic field. We're activating the secondary winding. And then when the voltage collapses and we open that gate back up, it's going to send all of that energy back down through the secondary winding, which is going to basically generate enough energy to jump the spark plug gap and create that combustion event. And now when we talk about going from the primary to the secondary winding, we're talking about a couple of thousand volts up to tens of thousands of volts in difference. So we have to build that primary, we have to get that magnetic field built, then we have to collapse that magnetic field down into the secondary. That way we can create that spark event and that combustion event. And then it just starts over again. And this is going to happen upwards of 50 times per second on each cylinder at around that 3,000 RPM mark. So why do we bring this up? The point we're making here by showing how this works is, yeah, we've got the primary, we've got the secondary, we've got a few thousand volts. We're going to build it into tens of thousands of volts. So it has to be robust. This has to be a robust unit. The ignition coil has to be able to withstand those thousands and thousands of voltages that are running through them over and over and over again as we drive down the road. And remember, we have and minimum, well, in some cases, minimum 3, but minimum 4 on these 3 and 4 cylinder engines. And that's 3 or 4 times at least that this is happening, over and over and over again as you're driving. So with these voltages the way that they are, we need a robust unit. And the reason for that is it's because of the reason that they failed the most common. And that is, obviously electrical failures. We can have overheating. We can have an electrical overload or a bad ground. We can have a spark plug gap issue. We can have, especially if we're doing high RPMs or towing, vibration. We can have moisture intrusion. We can have water and oil get in there. And so when I talk about it being robust, we need to make sure that the housing can handle the heat. We need to make sure that the connections can handle the heat and is also, and they're also secure. They're sealed so that we don't have, moisture intrusion getting in there. We have to make sure that it can withstand vibration. We have to make sure that the boot can withstand the heat. There's so much that goes into one of these coils to make sure that it's robust, because if it's not, the main failing points are when we find weak points in the coil. And when you find weak points in the coil, that's when you're going to start seeing one failure after another. So again, with all these voltages, all this heat, and all these cycles, these have to be very robust. And you see the point we make at the bottom here. There are some OE coils out there that have much higher failure rates than others. Some are just fine, but some are, the vehicles are in the shop week in and week out with coil failures. So a couple of tech tips that we can look at to avoid some things. First of all, again, ignition coils should never melt on their own, right? So if we have a melted coil, we need to investigate the root cause. And this is especially true, if we have a customer come in on the DIY side, or even a technician call from a professional, installation center and say, hey, I pulled a melted coil out of the vehicle, ordered one of yours, put it in, it melted as well. Well, it's very unlikely that it's the coil at this point. We've got something else going on. So we need to go investigate and make sure there's not a bad ground. There's not a high secondary resistance. We could also have a faulty coil driver. Maybe that's in the PCM. And we could also have a horrible lean fuel mixture, right? So we could have a situation going on with the rest of the combustion event that's causing an issue with the coils. So generally speaking, if you see multiple melted coils, there's something else going on. We need to further investigate. Another tech tip here, and this is an unfortunate one, but it is a true one. First of all, always remind your customers to disconnect the battery when they install a new PCM. There are a lot of occasions that when ignition coils fail, unfortunately, they take the PCM out with it. The perfect example would be the Ford 2-wire 4.6 liter and 5.4 liter engines. Those are a 2-wire coil. The command and the trigger is sent from the PCM, so the module is in the PCM. And so when one of those coils fails, it can take the PCM out with it. And unfortunately, oftentimes it does, and vice versa. The PCM goes out and takes the coils, out with it. So, anytime we're replacing a PCM because of a failed coil, we probably should go ahead and replace all the coils. But if we have one coil that's gone bad and it's messed up the PCM, we need to at least make sure when we replace that one coil, we replace the PCM along with it to make sure we don't have it take out other the other ignition coils in the process. But even if the PCM is good, everything is fine. Even if, we're replacing just the PCM, we need to make sure we disconnect the battery so we don't mess up any of the logic or the information that's stored in other systems. And then another quick tip here, always, always, always try to make sure we clean out the oil wells, the spark plug well where the oil can get trapped if we have a bad seal. So if we pull an ignition coil out and we see oil on it, we know we probably got a leaking valve cover gasket, or at the very least, spark plug tube seals. So I always recommend, if we have a customer coming in for ignition coils or even just spark plugs, make sure we ask, hey, when you pulled the plug out, did you notice any oil? If you did, we need to go ahead and take care of this gasket or these spark plug tube seals, or you're just going to be doing it over and over and over again. And that's going to end up causing ignition coil failures back to back to back. So there's a couple of quick tips and a couple of reasons why they fail, and really the gist of, the simplicity of how they work. We have a primary and a secondary that have to be able to get those voltages transferred over to get that spark event. We got to make sure we have a robust unit that can handle when that happens. And so with that, I'm going to pass it over to Jesse here to talk about some of our program and what our coils look like when it comes to how robust they are. So Jesse, the show is yours, sir.
Thanks a lot, Corey. The one thing I'd like to start with is the fact that this is such a huge category, right? Outside of rotating electric, this is the biggest underhood category. And there's a couple reasons for that. Yes, some of them are asked to work pretty hard. It's a high heat environment for sure. But the flip side of this is an awful lot of OE coils have really high failure rates, and that's because there's some major design flaws in a lot of OE coils. And I think as I say that, in your mind, you already know exactly which applications I'm talking about. Because an awful lot of the coil business goes through about 10 part numbers. And that's these numbers that have some high failure rates. It can be different design flaws, right? Some of them have moisture intrusion. Some of them don't have enough spark energy from the factory, and they're forced to work at maximum capacity all the time. They burn themselves up. Some are prone to overheating because they were under designed from the factory, don't have enough internal bobbin segments. But these three things keep coming up in the most popular applications. Another thing we should mention is that OE coils are designed and tested for a vehicle with how many miles? Zero, right? They work really well on brand new vehicles. My guess is your customers aren't working on brand new vehicles. They're probably working on vehicles with 150,000 miles. That's not what OE coils are designed for. As vehicles age with miles, with carbon buildup inside the engine, with older plugs that have a bigger gap, they start asking more and more of the coil. And OE coils just a lot of them can't keep up with higher mileage vehicles. So I just say this as a caution. There are some very good OE designs for sure, but specifically on these applications with really high failure rates, I think that OE service coils are probably not the best choice for higher mileage vehicles. Uh, I'd like to also quickly explain our product strategy because we do go to market with two different brands, and sometimes it can be a little confusing for people because we have two brands with no duplication, right? So why is that? Well, we don't have any duplication to help you improve inventory turns, free up shelf space. So each application will either be in a standard or a blue streak box. Now, what's the difference? The difference is that the standard coil matches OE design performance. And that will mean for not just OE form, fit, and function, but also internal bobbin designs, windings, spark energy, discharge duration. That's the standard coil. And I think if you were to look at this for the applications that you're selling the most of, there's probably not a lot of standard coils in the top 10 for your store. What you're probably selling more of is the Blue Streak coil. And here's why. Blue Streak coils have some very specific design improvements over the OE. So on applications that have high failure rates, specific issues that lead coils to failing more often, we redesign the coil, add engineering improvements to it, and then put it in the Blue Streak box. So the Blue Streak box always means you're offering more than OE. And that's exactly why the most popular coils that we have all end up being Blue Streak, just because those OE units that they're replacing fail much more often than the parts that we offer in the standard box. So it's not really a good, better, best thing. All of them are really the way OE should have made it. Standard is generally when OE got it right. Blue Streak has some specific improvements because OE didn't get it right. Now we can walk you through some of the choices that you have when speaking to your customers about their options with ignition coils. So, of course, there's a lot more low cost coils that are on the market, but there is a difference, and there's a difference in how they're made. What we've seen in a lot of these when we cut them open is the lower quality coils end up having fewer bobbin segments than what OE had. So you're passing too much energy through the inside of the coil. Um, Many of them have less spark energy, shorter discharge duration. Some of them over consolidate with cataloging and very, very limited sources for engineering and testing. Most of it's outsourced. So some of them just don't even perform as well as they could or should right out of the box. Another option that folks have is OE service. This will generally match OE design for bobbin segments. Um, but, again, kind of what we're coming back to before on applications that have some high failure rates, this might not be the best choice because it's really the same part that just failed. And what we've even seen more and more is that many OE service coils aren't even the exact same as what the OE coils are. They're not made in the same plant. They could be made in a different factory altogether than the original coil. And then, you have options like Blue Streak by standard. In this particular application, we've added an internal bobbin segment to spread out the energy a little bit more to allow the coil to run a little bit cooler. This coil is made in our own manufacturing facility, so it's completely in-house design, manufacturing, and testing. And with this unit, we've also built in additional spark energy and a slightly longer discharge duration that helps with atomization, but it also means the coil has more capabilities, right? So the coil doesn't have to work at 100% all of the time. The coil can work at 75, 80% during normal driving, and that allows the coil to last longer. And it really is the performance that of capabilities of a coil. That's the most critical thing. That's what's going to determine how long it's going to last. And like I said, when talking about our coil there, if a coil doesn't have to work as hard, it's going to last longer. This is spark energy measured on 3 different coils, OE, low cost, and then our UF406. And then we can also look at discharge duration. And the graph's going to look pretty similar, right? Where, there's OE, they're at 1 millisecond. Lower quality is even shorter. It's not going to ignite the fuel as well. You could certainly have some unburnt fuel going in. Ours has a slightly longer discharge duration. So that's going to work better for atomization. And again, certainly perform better if you're in a situation where you need more spark, towing, hauling, high RPMs, or if you get a little bit lower quality fuel. All of that helps to keep the vehicle operating correctly. There's some specific engineering improvements that we can speak to over the next few slides. Some coils fail because they end up getting moisture inside. And there's an OE design that certainly a lot of vehicles have used it, really common on some Ford coils, but it's a two-piece coil, right? It's not one solid overmold. It's two pieces that come together that are attached via an O-ring. And they generally work okay when they're new, but over time, heat, vibration, but primarily heat, it ends up just baking the rubber, starts to crack, and then you get moisture inside the coil as that O-ring starts to fail. So on these applications, we simply offer a solid one-piece overmold on the coil. So there is no O-ring. There's no place for moisture to seep in. So we are able to eliminate the weak point. No, there's also some things that we can do for heat insulation. This is the cover, the polypropylene cover that's used on a pretty common coil. Doesn't insulate the coil that well. And, after a couple high temperature tests, the epoxy starts to crack. and the coil starts to break down. It makes it too easy for moisture to get inside of the coil. So we've completely updated the overmold. We use an elastomer motor overmold. Certainly better properties, protecting against high heat, and along the lines of doing very similar tests. No cracks in the epoxy, right? Just allows the coil to last longer, as we could eliminate that weak spot. And then, something else that we do on a lot of applications is add bobbin segments. Many coils overheat. They just start to pass too much energy through each section, and they get too hot, they burn themselves out. This is an application where the OE has 5 internal segments. We have 7, with a little bit more spark energy. But what we're able to do by having these 2 additional bobbin segments, we're able to pass more energy through the coil, but reduce the amount of energy that's going through each segment, allowing the entire coil to run cooler, thus extending its life. And with that, I'll turn it over to the product team.
All right. Well, thanks, Corey and Aaron. Great info all around. So now that we've learned about how ignition coils work, some of the advantages standard and Blue Streak coils have over the OE, let's take a look at the competitive landscape here. As you can see, Standard leads the aftermarket with the highest SKU count and the broadest VIO coverage, and that's for all of North America, including Canada and Mexico. Now, we don't just want to provide the highest quality products to our customers, but also the exact product they're looking for to get the job done right. In addition to our industry-leading coverage for ignition coils, Standard also has thousands of related components available, including coil-on-boot service kits, ignition coil connectors, spark plug wire sets, and more. Now, we're proud to have the most complete ignition program in the aftermarket, but we're not resting on our laurels. We're constantly introducing new part numbers and updating our vehicle coverage, so you never miss a sale. Now, earlier, we shared some examples where our engineers spotted design issues in some OE parts and made improvements to create a more reliable, better performing, longer lasting ignition coil. This reflects our ongoing commitment to making the best ignition coils in the industry. And we use only the finest materials in every coil we produce, and over 60% of our coil on plug coils are manufactured in our state-of-the-art facility in Poland. And every Standard and Blue Streak ignition coil is designed with advanced features to ensure consistent performance, even under the most extreme conditions. Now, this slide highlights recent competitive testing we performed on our Blue Streak FD503K8 ignition coil kit. And just to be clear, this wasn't a comparison against regular aftermarket coils. We specifically tested against performance-rated competitors such as MSD, Excel, and NGK Mod. The coils were tested for discharge energy, current, and durability. And the table below shows that we tested these in a controlled environment and didn't keep pushing to a limit where the coils would fail. The goal was to ensure no damage while maintaining performance. And the bar graphs on the right, they compare spark energy before and after durability testing. And as you can see, FD503K8 maintained its performance while the NGK mod coils failed due to electrical damage, and the Excel mounting bracket broke after the durability test. And while Excel and MSD showed stable electric results, our Blue Streak coil stands above the competition when it comes to reliability and durability. Standard engineers and manufactures more than 6 million high-quality ignition coils and components every year at our advanced technology facility in Poland. This plant serves as a core design and engineering center, featuring state-of-the-art lean manufacturing methods with fully integrated processes, including injection molding, curing, and welding. Our Standard Premium Blue Streak ignition coils deliver the features and competitive advantages that come from the superior design, engineering, and testing that Standard is recognized for across the industry. And to ensure the highest quality ignition coils, every product manufactured at our Standard Poland facility goes through a full battery of measurement and life testing, along with a complete range of environmental tests, including thermal shock, thermal cycling, salt spray, vibration, and storage testing. Our coils aren't just tested in labs. They're also tested on actual vehicles at our vehicle testing center in Texas. And the result is a line of premium quality ignition components that perform flawlessly in real-world conditions. Well, that's my time, so I'm going to throw things back to marketing services. Aaron?
Awesome. Yeah, thank you very much. One topic I'd like to cover that it could be a nice way to help sales out for the store a little bit is how to recommend or suggest to your service provider customers that they offer coils in match sets. And a couple things to think about with this is, well, obviously it can certainly prevent future problems. Coils fail because of OE design flaws and or because of overheating, excessive vibration, some kind of contamination, some kind of moisture intrusion. So if one has failed for any of those reasons, it's very likely that another or others will begin to start failing in succession, right? They've all been subject to the exact same conditions. Another thing to remember about coils is that they're not a light switch. There are degrees into how well a coil functions. And as coils age, they lose their ability to perform as designed. So you end up getting less spark energy, sometimes even a shorter discharge duration. So if you have a vehicle with 150,000 miles, one coil fails, you put one on, and if there's 8 coils on the engine, yes, the vehicle will run again, but it's not going, installing one coil will not restore the performance of that engine or that vehicle. To bring the vehicle back to the way it was when it was new, or at least to help that, you will, you're going to need a set of 8 coils operating at or beyond what the vehicle came with from the factory. This is especially true for anybody that's going to be operating at higher sustained RPMs or towing, hauling, plowing, anything like that, where they're going to need the spark energy that that engine was designed for. And then another reason is just labor savings. Generally, when people are replacing one coil on a vehicle with 100,000+ miles, most shops are using that as an opportunity to check and replace all of the spark plugs. If the plugs are already coming out, if an intake has already been removed, there's not a lot of extra labor to replace one plug. So I think, sometimes, if it's a weird dud, one coil fails very prematurely, there's only a few thousand miles on it, or even, if miles is still low, maybe you can get away with just replacing one. But if the vehicle is 15 years old, 150, 200,000 miles, still has the original coils, certainly makes sense to replace them in a match set. In addition to everything that we've gone over from a quality standpoint, from a product standpoint, we also regularly create materials to support you in the field so that you're able to talk to your service provider customers about this category as well as all of our categories. There's printed materials available to you. There's an updated single page Ignition Coil What's in Your Box flyer. We also have a more robust 6-page brochure. We have a lot of material available to you. We have a YouTube channel with over 700 videos that I'll speak more on the next slide, but we also create really detailed digital product guides that are handy if you or anyone at the store wants to go a little bit deeper and get some more technical information on ignition coils. We update these once a year, and depending on the category, they're usually around 25 pages and do give you a nice deep dive into a product category. Over the past year or so, we've made several newer training videos. We've done 2 recently on ignition coils in our training series, both episode 6 and episode 15. They're only 3 minutes long. There's a little bit of a different flavor to them, but I would certainly encourage you to scan that QR code. That'll go right to the playlist. You can watch these videos or other videos and share them with some of the folks you work with as well, so they understand the program. Recently, our friends at Babcock's that publish several known aftermarket publications, Break and Front End, Shop Owner, Aftermarket News, Counterman, etc. Did a survey on ignition coils specifically. They asked parts professionals, how do you pick your brand? And they asked technicians, how do you select coils, right? What's your primary source? Well, why do you pick coils? The number one driver from parts professionals for suggesting a particular coil wasn't price. Price was only 2%. It was brand. It was a brand I trust. And for the technicians, it's, I mean, both matter for sure. It's brand and its availability. They care about that more than anything else. So when we look at the next slide, we'll see how well different brands scored among both these groups, among parts professionals as well as technicians. This was not an aided survey, meaning that the folks who responded wrote in the brands as they saw fit. But both groups chose standard, pretty far above all of the competitors, including OEM and some other very well-known aftermarket brands. Even on the technician side, it was standard was head and shoulders above the other brands. So it is a brand that that resonates with people. People like it, they know it, and they trust it. This is just a nice little cheat sheet that we threw in to offer some simple advice when you're on the counter recommending ignition coils to a customer, whether it's a shop or a walk-in. I think as as we've gone through this, that low cost coils are simply less than OE. They're less, fewer bobbins, fewer windings, less spark energy. Yes, they may look the same. The company may say OE form, fit, and function, but its capabilities are less. OE coils, some are okay. Others have pretty high failure rates, so they're not always the best choice. So if someone is, debating which coils to buy, they're not sure, just saying something like, if the goal is to restore engine performance and optimize fuel mileage, get the fuel mileage as good as it can possibly be by atomizing the fuel better with a longer discharge duration, then we recommend standard and Blue Streak ignition coils. I think that's it. It's a simple script that you can use each day. And then, just to wrap this up, what you're able to go to the street with, what you can sell is in-house design and manufacturing. That's pretty unique to us. A lot of folks out there selling coils are just repackagers. They're buying from different plants, largely in China. That's not us. We have a huge state-of-the-art facility in Poland where we design and manufacture coils. We have an awful lot of coils that have specific design improvements to address OE weak points. We have coils with additional performance capabilities that aids in engine performance, fuel mileage, and certainly extends reliability because it doesn't have to work as hard. Industry-leading coverage. That's nice thing about us is you can go to the street with a complete program, and we don't have coverage holes the way some of these other folks do. Very, very detailed in-house testing, in-lab testing, as well as on-vehicle validation, and the sales support materials that are sometimes needed to sway customers and to sway brand and tell them why Standard and Blue Streak are the best choice. So in closing, we just OE set the bar. Sometimes they did a great job, sometimes they didn't. But the aftermarket competition, especially the low cost, low quality, it just doesn't meet it. And with the Standard and Blue Streak program, we can quantify that we exceed it. So that's what we have for you this morning, and thank you very much.
And thank you, Aaron, and thank you, Jesse, as well. I think that's a lot of great information. And again, it's one of those things where I think it gives us some ammunition when we go out to have these conversations, especially with technicians and the professionals in the shop setting, making sure they understand that, when they call you for an ignition coil, they're getting the best version they can possibly get. And I think that's really what we're trying to drive the message home with today is make sure you're using a premium quality product. And you're going to find that in the standard in Blue Streak. And Aaron and Jesse, I think you did a great job explaining that. So thank you again, everybody, for being here. We hope to see you next month when we discuss VVT. And with that, have a great day. Have a great rest of your week. And hopefully you'll have some ignition coil sales opportunities very soon. Thanks, everybody.